Alright, hello algebra. Happy Friday. And today I'm at a track meet, so I decided that we're going to do the video thing again. So if you want to get your notes out and put your names on them and the date, we're going to get started here with a quick warm-up. So yesterday we talked about factoring polynomials, and we talked about how factoring is really just undoing distribution. And so we're going to warm up with a couple of distributing problems, and then we're going to get into the factoring part of what we did yesterday and a little bit of practice there. So for number one, we are going to distribute this 7x squared into this binomial. It's a binomial because it has two different parts. So when we do this, okay, you just take that and you distribute to both terms inside of our polynomial, our binomial. So 7 times 2 is 14. And then x squared times x squared gives you x to the fourth because you add those exponents. There are two x's here, there are two x's here. That makes 4 x's. Then we take 7x squared times 3x. 7 times 3 is 21. X squared times x is x to the third. And we are adding because both of these are positive. So that's what we get when we distribute. Okay? If we distribute this, x plus 4 times x minus 4, multiplying two binomials, okay, you can double distribute. So we take this x and we distribute it into both of those terms. We're going to take the 4 and distribute it both in. So x times x is x squared. X times 4 is 4x. And in this case, we have a positive and a negative, so we're subtracting. It's important to get that. Then we have 4 times x right here, our insides, and that is 4x. And we are adding because both of those are positives. And then 4 times 4 is 16. And we are subtracting because this is a negative and this is a positive. So minus 16. So then we have to look and see if we have like terms, and it so happens that we do right here in the middle. We have negative 4x and we have positive 4x, which when you put those together makes 0. Okay, so we have x squared minus 16 is our answer, because you can always leave out 0. It doesn't really matter. It's nothing. So x squared minus 16 is what we get when we factor this out. And we talked about both of these different cases yesterday. So we will start with something like this, and we have to go backwards to get to our original problem. So we're dividing the common factor out. So we're looking at what's in common between 14 and 21. Well, we know that 7 is the biggest thing, the biggest number that goes into both of these. 7 goes into 14 and 7 goes into 21. We also have to look at our variables and see what the biggest thing that goes into both of these terms is. So we know there are 3 x's here, x times x times x, and there are 4 x's here, x times x times x times x. And so the biggest thing in common between those two would be 3 of those x's, so x cubed. So that's how we can get 7x cubed out of those, okay? So actually inside of here we would be taking out another x because those are a common factor. And for this one, this is the difference of two squares, which we talked about and is a special case yesterday. So that is going to be what we are doing for the next couple of questions, factoring these binomials. So the first thing that we have to look for is the numbers, okay? And are there any common factors between 3 and 8? Well, you know that 3 goes into 3, okay? But 3 doesn't go into 8 an even number of times. It goes into 9, but 9 isn't 8. So then we have to try other numbers. 2 doesn't go into 3, but 2 goes into 8, but it has to go into both. 1 goes into both of these, but 1 is really kind of trivial, okay? If you can always divide by 1 and it doesn't change anything. So there's nothing in common for our numbers. But we have to look at our variables to find our factor here. So we look at x to the fifth and x squared. The biggest thing in common is x squared. It goes into x squared. It also goes into x to the fifth, okay? Because this is x times x times x times x times x, and there is x times x in that. So our factor here is x squared. This is what we need to divide by. So we're going to take this and divide by x squared. We're going to take this term and divide by x squared. Okay, that is our common factor for both of these terms. So since we divided by that, okay, we need to put that out in front. And then 3x to the 5th divided by x squared. If you remember back to our exponents, we subtract the exponent, so 5 minus 2 is 3. So we're left with, we're left with the number, okay, 3 from right here, and then x to the 3rd. And if you were to distribute that, you would get that back up here in this first term. And then we take this second one, the second term. So x squared over x squared, well, those cancel out, and you're left with 1. And so you have 8. And don't forget that you're subtracting. So x squared times 3x cubed minus 8 is our answer. And if you needed to check, all you would have to do is distribute that. Okay, so I'll show you guys the check here real quick. So as you're writing it down, you don't believe that this is hocus pocus and I'm just making stuff up. So x squared times 3x cubed is 3x. We add the exponents, so 2 plus 3 is 5. So 3x to the 5th. And then x squared times 8 is 8x squared, and we're subtracting. And this is exactly what we started off with, so that's our check. What I'm looking for our answer is this answer, or is this factored form. So I'll box it here for you. When I say please factor these polynomials, this is what I want you to do. Okay, get to that form. Alright, for 4, let's try and find our factor. So we have to look at our numbers. What is the biggest number that is in common, or that goes into both of these terms? So that goes into 15 and 3. Well, 3 goes into 3. Does 3 go into 15? And it so happens that it does. It goes in 5 different times. So our factor is going to have, zooming in and out here on accident. Our factor is going to have a 3 in it. Then we look at our x's, our variables. So there's an x here, there's an x squared here. So x times x and just x. The biggest thing in common between those two is one of those x's. So that's how we get 3x as our factor. So now we need to tell our viewer that we are factoring out a 3x. And what is left when we divide by 3x? Divide by 3x. So 15 divided by 3 gives us 5. And then x squared divided by x. Okay, 2 minus 1, if you're following the rules for exponents, 2 minus 1 is 1. So we just have x to the first, or x. Then we look at our second term here, 3x divided by 3x. Well, we notice we have the same thing on top as we do the bottom. And so if we have the same thing divided by the same thing, then it's going to be 1. And we are adding in this case because there's a plus in the problem. So this is our factored form. So let me box that here. And let's double check, okay? This is a super easy one to double check. So 3x times 5x plus 1, it's a 1. We distribute, okay, like our warm-up problems. 3 times 5 is 15, x times x is x squared, 3x times 1 is 3x, and we are adding. Both of those are positives. And that's exactly what we started off with, so we know we're good. And if you feel like you need to pause this at any point in time, if you're catching up, please feel free to do so. I don't want to go too fast, but I also don't want to make this video like 40 minutes long, because it's not a 40-minute video. So for number 5, we need to find our factor. What is in common for both of these terms, the 13x and the 39? So first off, let's look at the numbers, 13 and 39. Well, you probably have to take multiples of 13, okay? And we're going to have to see if there is a multiple of 13 that goes into 39. And 13 actually does go into 39. It goes into 39 3 times. 13 times 3 is 39. So we know our factor is going to have 13 in it. Then we look at our variables. Well, we don't have variables in both of these terms, so we can't have a variable in our factor. There's not an x over here, so it's not in both. So our factor is just 13. So we're going to pull a 13 out. We're going to divide by 13. So we divide by 13, divide by 13. So 13 divided by 13 for this first term is 1. And then we have that x left over, okay, right up here. 39 divided by 13, we said, was 3. And we're adding in this case. So another way we could write this would be 13 times. If there's only one x, you can just write x and then plus 3. Either of those options would be great answers. I would take either of those. So let's box that here. Oops. So that's what I'm looking for. And if we were to check, we distribute, and that's an easy one to see. We get back to our original problem. Moving on to 6, okay, we look and we see if we can find a factor, okay. So we look x squared, okay, so it's going to have to be a variable. And then 64, well, that one doesn't even have a variable. So there is no factor. There's nothing in common between x squared and 64. So what do we do? Well, if you remember from yesterday, okay, if we don't have a factor, we need to look and see if this second number, this 64, is a special number. So you think to yourself, 64. Well, I know that 64 is equal to 8 squared. 8 times 8 gives me 64. So, let's rewrite the problem maybe that we can see it that way. So we'll have x squared minus, and we're just going to replace 64 with 8 squared. Well, if you remember from yesterday, we did something called the difference of two squares. And right here I have x squared, and right here I have 8 squared. And I'm taking their difference, I'm subtracting them. So I know that if I have the difference of two squares, it's pretty easy to factor. All I need is two sets of parentheses, and I take what I'm squaring, so I'm going to take this x, and I'm going to take this 8, and I put it in both of the parentheses. So I'll have an x, I'll have an x, and I'll have an 8, and I'll have an 8. And the only difference between the two sets of parentheses is that one needs to be subtracting and one needs to be adding. Okay? So if you look at your problem and you're like, man, there's nothing that's in common between both of these terms, see if this is a special number, and that'll tip you off so that you can factor it out. And in this case, it factors out to two binomials, which is different from this, a monomial and a binomial. So you always need to be on the lookout for these special cases. This special case called the difference of two squares. Difference of x squared and 8 squared. All right. Moving on to our last two questions here. I'll move that down. All right. Number 7. 9x squared minus 25. Well, this is kind of a tough one because you have this 9 in here, okay? But anytime that you have a number, you always should be thinking, is it special? Is it something squared? And it happens that 9 is 3 squared, okay? So we have 3 squared right here. So not only do we have x squared, but we have 3 squared. And if we want to write 9x squared as just one thing squared, we can write this number, so 3, and then x, and have that squared. Because remember, 3x squared, I'll write this up here, 3x squared is just equal to 3x times 3x. And so 3x times 3x gives me 9x squared. And so they're the same thing. They're just different ways of looking at it. So 3x squared is the same as 9x squared. And we know that 25 is something special. It is 5 squared. And remember, we're taking the difference. We always have to take the difference. If this was a plus, we wouldn't be able to do this. So we have 3x squared and we have 5 squared. And so inside of our parentheses, when we factor this, we have to put the 3x in there. So 3x and 3x. And we have to put the 5 in there. 5 and 5. And the difference between these two parentheses is one's adding and one's subtracting. And it doesn't matter which order they go in. This could be a minus parentheses and this could be a plus parentheses. Doesn't matter. Okay? And this is our factored form. We factored this difference of two squares into two binomials multiplied together. So that's our answer. This is our factored form. factored form. And 8. 8's a little bit easier than 7. 7's kind of verging on a little bit of algebra too. We have x squared, but what's the big deal with this 1? Okay, and you always need to remember 1's kind of a special number. It's self squared, so 1 times 1 gives us 1. So you could do that forever. Actually, if you wanted 1 to the 5th power, you still get 1. So 1's kind of nice. So we can write 1 as 1 squared. So now we have the difference of 2 squares. So we know that we can put our parentheses in here, and we can put an x in both of these, and we can put a 1 in both of these. And the difference between these two sets of parentheses is that 1 is adding, 1 is subtracting. And that is our answer. So we have x plus 1 times x minus 1. And that will get us back up here. And you could double distribute and check if you really wanted to. Okay, and actually let's do that for the last one, just because I forgot to do it for the other ones. So x plus 1 times x minus 1, we'll do this super quick. X times x squared, x times, minus 1, or x times 1 gives you 1x, and we're subtracting. 1 times x gives you 1x, we're adding, because these are positive. And 1 times 1 is 1, and we're subtracting because a negative and a positive multiplied to give you a negative. So you look, and hey, we have like terms in here. Negative 1 plus 1 is 0. So then we're left with x squared minus 1, which is exactly what we started with. All right. So if you have any questions, you can always ask a neighbor. You can talk and get things figured out. But what we're going to do next is a couple of different activities. Okay. So for the remaining part of class, we have 2 things that we need to do. There isn't going to be any homework, so you don't have to worry about that. But I would like for you to below create your own factoring problem. All right, so think of 2 numbers that are related and put those there, and then variables. Okay, so use numbers and variables. If you needed to do a distributing problem, so if you make a distributing problem and then you give that to someone else, that would be fine too. But what we're going to do is we're going to make your own factoring problem, and then you're going to give it to another student and challenge them to solve it. All right, and you need to make sure that your questions work out kind of nice. Okay, and if they can't solve it, then you help them out. Okay, you kind of teach them and show them, well, this is kind of what I was thinking, because sometimes you make mistakes and you don't know it, and it's good to talk about it. So that's what we're going to do, and you can do this on the front or the back of this page. That's why I gave you a lot of space on the back. The last thing that we're going to do is a little match activity. Okay, so take 5-10 minutes to do the create your own problem and challenge someone else, and then for the rest of the class, we're going to match things up. Okay, so I'm going to have, don't know what that is. So we're going to have a packet of different things, and you guys can work in groups of like 4 or 5, but I want you guys to match up the factored form and the distributed form, and those need to go together. They're going to be a lot, so work on that. Once you get them all organized and matched up, then you're free to talk quietly or work on homework that you have. So thank you guys, and I hope you guys have a great Friday and a great weekend. I will see you guys on Monday. Thanks.